Today we're going to study two concepts of math. It'll be geometry and probability for a combination of geometric probability. So you get a 2-for-1 day today. And just to provide some brief examples on to set a tone for the day, I have a couple of examples. One pulled from the news and one pulled from a recent study I was doing related to student teaching. The first one, you've all heard about the missing Malaysian air flight that went missing somehow in March of 2014. After a 4-month hiatus, they are getting ready to resume the search. And it's a 23,000 square mile search area, 1,100 miles off the west coast of Australia. And one of the tools they're going to use is called the Bluefin 21. It's an automated underwater vehicle. They'll send that down to the bottom of the ocean, and it will map the ocean floor looking for signs that there is plane wreckage down there. And the Bluefin 21 can map out 56 square miles per day. So with a 23,000 miles search area, 23,000 square miles search area, and the Bluefin being capable of mapping out 56 square miles per day, we can figure out the probability that they'll find any wreckage in that search area if it exists, say in a day, in a week, in a month. So we can use that data. The second example I have is one that I was doing when I was looking at probable student teaching locations. I want to teach in the Pittsburgh area, so ideally either downtown Pittsburgh or in the near suburbs. And I mapped out where my house is in McCandless and drew a 10-mile radius. Using that information and the fact that I constructed the Pittsburgh area as a 20 by 20 square mile rectangle, we can figure out if the student teaching assignments are assigned randomly in the Pittsburgh area, what the probability is that I would find something in my 10-mile radius. So with that information in mind, please take a look at the flip page of the handout, flip side of the handout, and I have some statements here. And we're going to go through these statements before the lesson and indicate whether or not they're true or false, based on what you know now. So you can read through them. First one, circle is a figure that measures 180 degrees, true or false. The second one, diameter, the segment that connects the center of a circle to a point on the circle, true or false. Radius, the segment of a circle that connects 2 points on a circle and passes through the center. Sector of a circle, the region of a circle created by 2 radii. Area of a rectangle, length times width. Area of the sector of a circle, pi r squared, where r is the radius. Area of a circle in degrees, theta, which is the measure of an angle, over 360 times pi r squared. Concentric circles, 2 or more circles that share the same center but have different length radii. Now we get into probability. Probability, the likelihood that an event will occur. Theoretical probability, think a bunch of US stats class. Maybe you already know this one. Theoretical, the probability based on the results of a given formula of probability. And experimental probability, the probability based on actual trials and the results of those trials. So have y'all gone through these, answered true or false? We'll circle back to these at the end of the lesson, and you can correct or change if you think it's true or false, and if it's false, indicate why it's false. All right? So now we'll get to the objective of the lesson, which is looking at geometric figures, their area, and calculating probability.